In this lesson, we are going to talk about the second form of interest rate, which is called the compound interest. Before I derive the formula for compound interest, we have to define a couple of terms here. First is the compounding period. We define the compounding period as the time interval after which the compounded interest is calculated. For instance, this means that if R is the compounding interest and the compounding period, let's say, is 1 year, then compounding period, which is 1 year, is the time that the interest on the initial investment is going to be calculated. So if you invest $1,000, after 1 year, which is compounding period, the bank is going to find what is your interest, which is going to be accumulated on $1,000, and it's going to add it to $1,000. Let's say we get a number which is shown with a square here. Now another year is passed. Now the compounding period, which is 1 year, after 1 year, we are going to calculate interest on this one again, not on the original principal. Remember, in simple interest, you were always finding the interest based on the initial investment. But now, the initial investment for this compounding period is going to be here. So the interest is evaluated on this guy, and then you get another one here. And this process is going to continue for every compounding period. We also define another term called compound interest. This is the interest rate which is used within every compounding period to find the amount of interest on your investment. In the first example, we have to derive the formula for the amount of a compounding interest. Let's assume that you invest P dollars. Your principal is P. The compounding interest is R. And the amount of time that you are going to invest your money is T years. So initially you have P dollars. After 1 year, so this is 1 year past, you know that you are going to accumulate some interest on your initial amount, which is P. That interest is going to be PR. You just multiply the interest rate times your initial investment, which is P. And then you add it to initial investment, which is P. So you're going to get, if you factor P out, you get 1 plus R. Let's say another year is passed. So 1 more year is passed. Now you have to find the interest on your initial investment, which is P times 1 plus R. Now to find the interest on this one, we are going to multiply this by R. So I'm going to get P times 1 plus R times R. And then you add it to the initial investment now, which is P times 1 plus R. Now if you look here, P times 1 plus R is common. So if I factor P times 1 plus R out, I get R from the first one, and I get 1 from the second term. And there are two 1 plus R which are multiplied together, so I get P times 1 plus R squared. So this is my investment after 2 years. If you look at this one, you can see that the pattern after 1 year is P times 1 plus R exponent 1. After 2 years is P times R exponent 2. So you can guess exactly what is going to happen after n years, which is P times 1 plus R exponent n. Now, remember here n was in year because your compounding interest was R annually. But in general, n is the number of compounding period. So the general formula for a compounding interest is A, the amount, is equal to P, the initial investment, times 1 plus R exponent N. So A is the future value, P is the initial value or initial investment, R is the compounding interest, and N is the number of compounding periods. In the first example, we have Ashutosh, which wants to buy a guitar, and he borrows $650 and plans to repay it in 5 years. The bank charges 12% per annum or annually, compounded annually. Determine the amount that Ashutosh must repay after 5 years. So we know that A is P times 1 plus R exponent N. The initial loan is $650. The interest rate is 12%, so 12 divided by 100. And the compounding is annually, so N has to be represented as the number of compounding periods. And since we have 5 years, so this is 5. So if you simplify this one, you're going to get $1,145.52. The next part of the question says how much interest will Ashutosh have to pay. Is very simple. We know that he borrowed $650, but he paid $1,145.52. So the difference is the interest rate. So the interest rate is 1145.52 minus 650, which is going to be $495.52. The next part of the question says compare this to the amount of interest he would pay if the bank charged simple interest. For simple interest, I is PRT, or P is 650 times R is 12%, so 12% times 5. If you simplify this one, you get $390. So instead of paying $495.52, he would pay $300 if the interest was a simple interest. In this example, we are going to talk about different compounding periods. For example, one compounding period is semi-annual. Semi means half. So this means that your interest is going to be, your principal is going to accumulate interest every 6 months. Another type of compounding period is quarterly. This means that 4 times a year or every 3 months you are going to receive interest. Now let's look at the previous example, which Ashutosh, he got $650, so P is 650. The interest rate R is 12% for 5 years. We want to know what is the impact on the interest Ashutosh is going to pay if the interest is compounded semi-annually. We know that the compounding period is every 6 months. So this means that your interest rate is 12%, which is 0.12, is 1 year. So for 6 months, what we are going to do, we are going to divide this one by 2 to get the interest rate for every semi-annual. And since N is 5 years, we have to multiply this by 2 to get the number of semi-annuals. This means that our main formula, which was A is equal to P times 1 plus R exponent N, is going to change in the following form. P is 650, but R is 0.12 every year. So it's going to be 0.12 divided by 2 because it's semi-annual. And your N is 5, but it's going to change to 5 times 2 because there are 2 semi-annuals in every year. If you evaluate this one, then you are going to find that this is 1164.05. So the interest now that he has to pay is going to be 1164.05 minus 650, which is going to be 514.505 cents. Now we are going to talk about the case if the interest is compounded monthly. Again, we are going to write the given information. First, our loan is $650. Interest is 12%, which is 0.12, and N is 5 years. Now, this 0.12 is annual interest rate. So monthly, we have to divide it by 12. And also 5 years, every year is 12 months, so you have to multiply 5 by 12. So this means that A in this case is going to be P, which is 650, times 1 plus the interest rate, which is 0.12 divided by 12, because again, the compounding interest is monthly, and there is 5 years, so 5 times 12. If we use our calculator and evaluate this expression, we are going to find that this one is $1,180.85. So the interest is going to be the amount minus the initial loan, which is $650, which is going to give us $530.85. This is our interest rate, the interest that he has to pay after 5 years. In the next example, we have Janvi, which is starting a small business. She applies for an $8,000 loan. So we know that P is $8,000, which she plans to repay in 4 years. So N is 4. She is told by the loan officer that the amount payable when the loan is due is 11. So this means the amount or the future value is 11,501.24. We have to find the interest, if assuming that the interest is compounded annually. So this means that 11,501.24 has to be equal to P, which is 8,000, times 1 plus R exponent N. N is 4. So I'm going to go and divide both sides by 8,000. So from here I get 1 plus R exponent 4 is 11,501.24 divided by 8,000. Now to isolate R, I'm going to take root 4 of both sides. If you remember in exponential functions, we said that if I take root 4 of both sides, I'm going to have 1 plus R is going to be root 4 of 11,501.24 divided by 8,000. Now I'm going to move 1 to the right, so I get R is root 4 of 11,501.24 divided by 8,000 minus 1. Now you may say, how can I calculate root 4 of this fraction? Remember, root 4 is the same as a number exponent 1 over 4. So what you have to type on your calculator is the following. You type open bracket 11,501.24 divided by 8,000 close bracket, hat 1 divided by 4 minus 1. If you evaluate this one, you will get approximately 0.095, which is equal to 9.5%.